We know from previous videos that if two triangles are similar, they will have the same shape, but they will not be the same size. In mathematics, when working with similarity, we use this symbol. So as an example, we can say triangle ABC is similar to triangle DEF. To prove that two triangles are similar, we need to show that corresponding angles are equal or that corresponding sides are in proportion. We've already looked at corresponding angles, so now we're going to look at corresponding sides. So what exactly are corresponding sides? Let's draw two triangles. Let's call the one on the left ABC and the one on the right PQR. And let's write ABC down here and PQR down here as well. Now, in our previous video, we learned that if you are looking for corresponding angles, we look at the letters in each name. A is the first letter in ABC, and P is the first letter in PQR. So A and P are corresponding angles. This rule applies to all three corresponding angles in our triangles. Now we can use a similar idea, but now we focus on the sides of the triangles. A and B are the first two letters in ABC. So in triangle ABC, let's make the side AB red. P and Q are the first two letters in PQR. So let's look at the triangle and make PQ red. A and B are the first two letters in triangle ABC. And P and Q are the first two letters in PQR. So AB and PQ are corresponding sides. In ABC, B is the second letter and C is the third. So in the triangle, let's make BC purple. In PQR, Q is the second and R is the third. So let's make the side QR purple. In ABC, B and C are the second and third letters. In PQR, Q and R are the second and third letters. So BC and QR are corresponding sides. Finally, A is the first letter and C is the third. So let's make the side AC green. In PQR, P is the first letter and R is the third. So let's make PR green. A is the first letter and C is the third in ABC. In PQR, P is the first letter and R is the third. So AC and PR are corresponding sides. When we worked with corresponding angles, we had to prove that corresponding angles were equal because similar triangles have the same shape. But similar triangles are not the same size. So corresponding sides will not be equal. They will be in proportion. If you take a side of one triangle and divide it by the corresponding side of another, you will get a fraction. If the sides are in proportion, you will get this fraction as your answer if you divide any pairs of corresponding sides. So what exactly does this mean? Well, let's look at the different pairs of corresponding sides. Let's say that AB is our first side of triangle ABC, and we know that PQ is the corresponding side in triangle PQR. So we can write our fraction as AB over PQ. Let's say that BC is the second side of triangle ABC, and we know that QR is the corresponding side in PQR. So we can write our fraction as BC over QR. Finally, let's say that AC is the third side of triangle ABC, and we know that PR is the corresponding side in triangle PQR. So we can write our third fraction as AC over PR. Now, if these sides are in proportion, then AB over PQ will be equal to BC over QR, which will be equal to AC over PR. To prove these sides are in proportion, we need to find the actual values for these fractions and show that they are equal. Let's make our triangles blue again and give the sides of each triangle a specific length. Now we can find the value of each fraction. Let's start with AB and the corresponding side PQ. So now we can say side AB over the corresponding side PQ. A is 2 units long and PQ is 4 units long. So we get a fraction of 2 over 4. 2 and 4 are both divisible by 2, and we get a fraction of 1 over 2. Next, let's look at side BC and the corresponding side QR. So we can say side BC over side QR. BC has a length of 3 units and QR has a length of 6 units. So we can say 3 over 6. 3 and 6 are both divisible by 3. So we get a fraction of 1 over 2. Now we have two equal fractions, both of 1 over 2. So we can see that these corresponding sides are in proportion, and there's a very high chance that these two triangles are similar. When we looked at corresponding angles, we only had to prove that two pairs of corresponding angles were equal, and then we could assume that the third pair was equal too. But when working with sides, we have to show that all three pairs of corresponding sides are in proportion. So let's look at side AC and the corresponding side PR. Now we can say side AC over side PR is equal to the length of AC is 4 units and the length of PR is 8. So we get a fraction of 4 over 8. 4 and 8 are both divisible by 4, and we get 1 over 2. Now we can see that all fractions are equal to 1 over 2. So these two triangles are similar. So we can say triangle ABC is similar to triangle PQR. The reason why these triangles are similar is because all three of corresponding sides are in proportion. So we write our reason as S, S, S. Now we can look at some examples. Prove that triangle ABC is similar to triangle EFD. To prove that these triangles are similar, we need to prove the corresponding sides are in proportion. So let's start by determining our corresponding sides. A and B are the first two letters in ABC. So let's mark this side in red. E and F are the first two letters of EFD. So EF is the corresponding side. Let's mark this in red as well. B and C are the second and third letters in ABC. So let's mark line BC in green. F and D are the second and third letters in EFD. So let's mark side FD in green as well. A is the first letter in ABC and C is the third. So let's mark side AC in purple. In EFD, E is the first letter and D is the third. So we can mark side ED in purple as well. Now, if these two triangles are similar, then each pair of corresponding sides will be in proportion. That means that side AB over the corresponding side EF will be equal to side BC over the corresponding side DF will be equal to side AC over the corresponding side DE. We have been given the lengths of all three sides of each triangle. So let's put these values into our fraction. Let's start with AB and its corresponding side EF. So we can say AB over EF. AB is 8 centimeters long and EF is 24 centimeters long. So we get a fraction of 8 over 24. 8 and 24 are both divisible by 8. 8 divided by 8 gives us 1 over 24 divided by 8, which is 3. AB over EF gives us the fraction of 1 over 3. Now let's look at side BC and its corresponding side FD. So we can say side BC over the corresponding side FD. BC is 7 centimeters long. So we can say 7 over FD is 21 centimeters long. So we say over 21 is equal to 7 and 21 are both divisible by 7. We get a fraction of 1 over 3. Now we know that two pairs of corresponding sides are in proportion because both fractions give us 1 over 3. So let's find the third pair of corresponding sides, AC and ED. So we can say AC over ED is equal to the length of AC, 6 centimeters. So we say 6 over ED, which is 18 centimeters. 6 and 18 are both divisible by 6. So we can simplify. We get a fraction of 1 over 3. Now we know that all three pairs of corresponding sides are in proportion. So these two triangles are similar. So we can write our final answer as triangle ABC is similar to triangle EFD. This is because of corresponding sides. So as our reason, we say S, S, S. Let's do another example. Consider the sketch and prove that triangle GHI is similar to triangle JKL. Let's start by finding our corresponding sides. G and H are the first two letters in GHI. So let's mark this side of the larger triangle in red. J and K are the first two letters in JKL. So let's mark this side of the smaller triangle in red as well. GH and JK are corresponding sides. H and I are the second and third letters of GHI. So let's mark HI on the larger triangle in purple. K and L are the second and third letters of JKL. So we can mark this side of the smaller triangle in purple as well. Finally, GI, G is the first letter, and I is the third letter. So let's mark GI on our larger triangle in green. J is the first letter, and L is the third letter of JKL. So let's mark JL in green as well. This is our third pair of corresponding sides. Now, if these triangles are similar, the corresponding sides will be in proportion. That means that GH over the corresponding side JK will be equal to HI over its corresponding side, KL, and these will be equal to GI over the corresponding side, JL. Now we need to prove that these fractions are equal. Let's start with GH, the red side of the larger triangle, and the corresponding side of the smaller triangle, JK. So we can say GH over JK is equal to, GH is 5 units long, so we can say 5 over the length of JK, which is 3. This fraction cannot be simplified, so let's leave this as it is. Now let's look at HI, the purple side of the longer triangle, and KL, the corresponding side of the smaller triangle. So we can say HI over KL. HI is 7,5 units long, so we can say 7,5 over the length of KL, 4,5. Now we have decimals in our fraction, so we need to simplify this. When we simplify fractions, we usually divide the numerator and the denominator by a common factor. But if we were to do this now, we would just get more decimals. Remember that what you do to the top, you do to the bottom. And as long as you do the same thing to the numerator and the denominator of the fraction, the value of the fraction will remain the same. So let's multiply our numerator and our denominator by 2. 7.5 multiplied by 2 gives us 15 over 4.5 multiplied by 2, which is 9. 15 and 9 are now both divisible by 3. 15 divided by 3 gives us 5 over 9 divided by 3, which is 3. This fraction is now in simplest form, and it is the same as the fraction we've just found. So let's move on to GI, the green side of the larger triangle, and JL, the corresponding side of the smaller triangle. So now we can say GI over JL. GI is 10 units long, so we can say 10 units over JL, which is 6. 10 and 6 are both divisible by 2. 10 divided by 2 gives us 5 over 6 divided by 2, which is 3. Now we've proven that all three fractions are equal, which means that all three sides are in proportion, so the two triangles are similar. So we can say triangle GHI is similar to triangle JKL because all three sides are in proportion. So as our reason, we say S, S, S. Let's do one more example. Consider the sketch and prove that triangle MRP is similar to triangle QNP. Here we have two triangles within the same diagram. So let's start by finding our corresponding sides. M and R are the first and second letters in triangle MRP. So let's mark this side in red. Q and N are the first and second letters in QNP. So we can mark this side in red as well. R is the second letter and P is the third letter in MRP. So let's mark this side in purple. N is the second letter and P is the third letter in triangle QNP. So let's mark this side in purple as well. Finally, let's look at M, the first letter, and P, the third letter in triangle MRP. Let's mark this side in green. Then Q is the first letter and P is the third letter in triangle QNP. So we can mark this side in green as well. If these triangles are similar, then corresponding sides will be in proportion. That means that the side MR over the corresponding side QN will be equal to side RP over its corresponding side NP, and these both will be equal to side MP over the corresponding side QP. Let's start with MR, the red side of the large triangle, and its corresponding side QN. So we can say MR over QN is equal to, MR is 12 units long, so we can say 12, over QN, which is 9. 12 and 9 are both divisible by 3. 12 divided by 3 gives us 4, over 9 divided by 3, which is 3. Now we can look at RP, the purple side of the larger triangle, and the corresponding side NP of the smaller triangle. So we can say RP over NP is equal to, RP runs from R to Q and Q to P. So RP is 8 units plus these 12, which gives us a length of 20 units, over NP, which is 15 units. Now we can simplify our fraction. 20 and 15 are both divisible by 5. 20 divided by 5 gives us 4, over 15 divided by 5, which is 3. This is the same fraction as we found above. So let's look at our third sides. MP is the green side of the larger triangle, and QP is the corresponding side in the smaller triangle. So we can say MP over QP is equal to, MP runs from M to N and then to P. So the length of MP is 1 unit plus 15 units, which gives us 16 units, over QP, which is simply 12. 16 and 12 are both divisible by 4. 16 divided by 4 gives us 4, over 12 divided by 4, which is 3. Now we have 3 equal fractions, which means the sides are in proportion, and these are similar triangles. So now we can say triangle MRP is similar to triangle QNP because all 3 sides are in proportion. So our reason is SSS for side, side, side.